Hello and welcome to Data Science Crash Course. This is episode 7 about clustering. We covered classification in the previous episode. Clustering is about working with unlabeled data. So we're talking about unsupervised learning. You don't have any labels, you just have raw data and you're trying to make sense of that. So that's a common scenario actually in real life whenever especially we talk about social statistics in social sciences or about marketing. So a common use case for that would be you have a person who's buying a MacBook and you want to understand who are similar people, who's similar to him, her, who you might also market, for example, and who would be also interested in buying a MacBook. Or you can try to understand, for example, who's going to musicals in New York, based on who's buying tickets, whether that's based on income, area of location, and different kind of metrics like that. So this is really standard examples because everywhere in marketing, everywhere in social sciences, you're trying to understand different group of people and making sense of those and looking at the similarities, looking at what really connects those people, those groups of people is crucial both in marketing and in social sciences. And this is what clustering is all about. So we're trying to cluster, which means we're trying to find groups which are similar. And the very first technique that you have for clustering is K-means. K for number of clusters that you want to get into. So for example, 3 means that you're trying to put your data into 3 clusters based on similarity. So this K3 in this example is something artificial in the sense that it's arbitrary, you're giving that a priori. But there's a way to determine the best number of clusters for a given data. That's called, for example, elbow method. And there are a couple of other methods you can use to determine how many clusters you should have. By basically plotting distortion. Because, okay, so that's more complicated, but if you Google distortion, if you Google elbow method, then it became clear how you do it based on plotting different clusters and their centers. So yes, this clustering is about metric spaces because you need to have a sense of a distance, you need to have kind of a metric, so you need to measure how things are similar, how far away they are, and for that you use a metric. Fortunately, we here talk about only numeric data, and with numeric data that's clear that you can just compare how far away is a given vector from another vector. So we have no problem with that, with the sense of a distance. So that's really great. And basically, K-means is the simplest method for to use to determine different clusters. You have to experiment with a couple of clusters each time, with the different numbers of clusters in order to see what works best. But you can just start going on. It's really quickly, it's very quick to do, especially when you use sklearn, so part of scikit-learn library. It's it's about like 10 lines of code all in total to do this kind of fitting for the data you might have. A little bit more complicated technique is DBSCAN. So that stands for density-based spatial clustering of applications with noise. So it's also about clustering, but it's about this time. It works a little bit like K-means. So K-means works like you're looking at the different similarities, different distances, and trying to determine the centers of clusters and see whether you can find this object, and then from that build the circles. DBSCAN works a little bit. It's a little bit similar, but actually you start with small circles because you look at the small neighborhoods to start with and trying to determine, and from that you try to find neighbors, you define the neighbors, and you go on with that. So noise stands for a parameter epsilon, which appears in DBSCAN. The technique is a little bit complicated, but it also often gives much better results. the best way to learn is to practice. So I recommend for you to try with some kind of data to do both Kmeans and DBSCAN and see the results. And of course, for Kmeans, compare different number of clusters that you're using. That's the most efficient way to learn. So the best data for clustering are definitely the different demographics and what people like not, and then try to compare that into the different groups, for example, of buyers, customers. If you're running a business, this is definitely something useful and something you would like to do. So I've seen clustering appearing in real life in many startups, in many businesses over and over again. And actually, it's always the same kind of techniques that you're using. So actually, it's not about what kind of sophisticated algorithms you will use, but rather how you will apply it, to what parameters, whether you would clean data or not, and how you would clean data, because data science is actually all about data. So you have to understand how to clean the data in the best way first, and only then you can apply algorithms. Thank you for watching. I hope you've learned something, and we're slowly coming to the end of this data science crash course. The next episode will be about neural networks.